All right, so for this, we need a periodic table handy. We need your notes and your enthusiasm for calculating things. All right, so this topic, percent composition, this is going to be tied into something called empirical formulas. We're going to at least get through the percent composition stuff today. So go ahead, put away your whiteboard. You can set your whiteboards aside. You should be taking notes on your notebook. We can do percent composition of pretty much anything. So we could even look at what is the percent composition of freshmen in this class, or percent composition of people who live in Grandview, or percent composition of people who have been out of the country in the last 2 years. So let's see if we can do that last one. How many of you have been out of the country in the last 2 years? Hold them up really high. So 1, 2, 3, 4. So we have 4 people who have been out of the country in the last 2 years. I don't think I've been out of the country. I don't think so. And now how many people are in the room total? 16. Let's make it count me as well to make it easy. So there's 4 of you who have been out of the country. There are 16 total. So what is the percent composition of students who have been out of the country in the last 2 years? 25%. So if you take 4, the number of people who fit the category, 4 divided by 16 is 25.25, and then multiplied by 100, we get 25%. Okay? You can do percent composition of anything you want. Okay, and you take the amount of people who fit the category divided by the total number of people in the category times 100. Okay? Well, we're going to do this with chemistry things. So chemists tend to make new compounds, and then they need to analyze those compounds and make sure that they really are what they say they are. Okay? So percent composition for chemistry is the percentage by mass of each component within the compound. So the mass percent is the percentage by mass of each element within that compound. There's an easy equation to use to calculate this. We have percent composition equals mass of the element and then divided by the total mass of the sample. Okay? Now sometimes we know the formula of the compound, sometimes we don't. So sometimes we just have masses of each element. I'm going to show you multiple practice problems where I'm giving you different kinds of scenarios, and then so that we can practice those before you have your homework that goes with it. Okay. So do you all have this equation written down nice and big in your notes? We're going to keep on using this all class. Okay. So pretty much this lesson is a lot of practice problems, not a whole lot of extra notes. So we have find the percent composition of copper and sulfur in this compound, Cu2S. The first task I want you to do is we're going to keep on remembering about how to name compounds. So if I've got the formula, we can come up with the name of this, right? First off, what kind of compound is this? Is it an ionic, covalent, or an acid? It's got a transition metal, so it's definitely ionic. Then all we need to do is name each of the ions. So, what's the cations? It's copper. And what is the anion? But what do we do with the anions? The endings. We need IDE endings. So IDE, we have copper sulfide. Is that all I need? What else should I do? I need my Roman numerals. Well, what is going to go in the Roman numerals? How do I know what to put in here?
Add charge of the sulfur.
The charge of the sulfur is going to tell me what the charge of the cation is, right? So the sulfur always is what charge? -2. And so if I've done crisscross and I got the -2 charge, there are 2 coppers, so each copper has to be what? +1. So then I have copper 1 sulfide. Okay, so we haven't forgotten it. So now we have copper 1 sulfide. We're going to go through and find the percent composition of both elements within that compound. We have copper and we have sulfur. So when I'm finding the mass of each element, I have to include the mass of the subscript as well. So if I've got Cu2S, then the mass, if I'm using that mass of the copper, how many coppers do I have? 2. So I'm going to take 2 times what? 2 times the 63.55 grams of copper on the top. Well, then on the bottom, I want the mass of the total sample, which is Cu2S. So now you need to take the mass of the copper and the mass of the sulfur, add them up. What is the molar mass of the whole sample? There's 2 coppers plus my 32.07 from sulfur. So I'm hearing 159.17. So we have 0.16, same thing. Are we good? Yeah. So on the bottom you should have the 2 coppers plus the sulfur is 159.17. So now we have the mass of the copper on top divided by the mass of the whole sample on bottom times 100. So calculate out what is that percentage of copper. What did we get? We agree? How about this? I said 79.852. Are we all right though? We are all around 79 point something. It's probably just a little bit of rounding with our molar masses at that point. So this is fine. 79. I've got 5 significant figures because each of my masses has those 5 sig figs, which is fine. Okay. So 79.852. Well then, what about the mass percent of sulfur? How do we do this? Elaborate. Yeah, we're going to go the route of actually calculating out. Subtracting can get us into trouble only because if we mess up this part, we're going to mess up the second part. So we're going to calculate, we're going to just take the mass of sulfur and divide it by the same molar mass, 159.17. What is that? And then times by 100. What is that percent? 20.15. Now you can check your work. When you add these 2 up, what do you get? 100%. This is how you know if you've done it all correctly. If it adds up to 115%, you have a problem. So you want to make sure that you have that way of internally checking your work, rather than if you just do the subtraction, you don't have any way of verifying that it's correct. Okay. So that's it. That's how you do a percent composition. Now we're going to apply that a little bit here. Sometimes you make your sample and you have a mass of that sample. So you've got 38.0 grams of your copper sulfide. And maybe you want to figure out how many grams of copper you can get out of it. Okay. So what could I do here? Do I know anything about how much copper should be in the sample? How much of the sample should be copper? 79.852% of that sample should be copper. So if I have 38 grams of the sample and 78% should be copper, or 79 should be copper, what math can I do? Just multiply them out. So I'm going to take my mass of my sample, multiply it by my percentage, and my animations are not very helpful today, but check this calculation. And then Sammy, it's 10:30. Okay. You've written down the homework? Did I do my math correctly?
Yes.
Okay, good. So we have 30.3 grams of that sample is copper. That should make sense. About 80% of a 38-gram sample, 30 grams. Sure. So I should be able to extract 30 grams of copper out of that sample through some chemical means. Okay? That's another example of a problem. I have another one for you. Okay? This next one, I have taken my sample, I have done the analysis, and I got the results back that said I have 28 grams of iron in my sample, and I have 8 grams of oxygen. So now if I want to find what is the percent composition of my sample, what can I do? I'm still using the same equation, right? I'm using, if I want percent of iron, I'm going to use the mass of the iron divided by what? The mass of total. So what is the mass of iron? 28. What's the mass total? 36. I add them up. 28 plus 8. It's 36 grams. Times by 100, and what do I get? Talk to your people. See if you agree. I'm hearing a lot of 78%. Good. It's 78%. Now what do we do for the oxygen? We're going to take the mass of the oxygen divided by the mass of the sample times 100, and what do you get there? Calculate that out. You should get 22%. Does this add up to 100? Yeah. Okay. Pretty easy, yes? All right. The next one I want to show you has to do with a different way we can write the formula of a compound. Some compounds come as these things called hydrates. All it means is that in that ionic substance, in the crystal, there are water molecules that have been trapped inside. So those water molecules contribute to mass in the sample. And there's also a very specific ratio of the ionic compound to the number of water molecules. Okay? So you see this formula, it says find the mass percentage of water within a calcium chloride dihydrate, which that formula, when written out, it has the calcium chloride, just like you've been writing formulas all along, but then that dihydrate is written with a little dot, and then the di says there's 2 of them, and then the water is the hydrate, H2O. That dot does not mean multiply. Maybe when you write out that formula, you put a note into your notes that says does not mean multiply. Or you could just sit there and stare at me. You could write this down, right? So the dot does not mean multiply. But it does mean that that whole thing is a compound. That means when you're finding the mass of that compound, you have to include the waters in that formula mass. Okay? So if I'm going to find the mass percentage of water, I'm going to use still the same equation. It's just now it's percent H2O is equal to the mass of H2O divided by the mass of the total thing. What? So you're going to find the mass of water, and then you're going to find the mass of the whole thing. In this case, I don't really care about the mass of just calcium chloride. That won't be important. Right? But if I'm doing mass of water, I need to include all of the water. So how many hydrogens am I finding the mass of here? There's 4 hydrogens. How many oxygens? How many? There's 2. So if I get 4 hydrogens and 2 oxygens, what is that mass? Calculate it out. Do the work. You're involved. You use your periodic table. Find those elements. Add up the mass of just the hydrogens and oxygens. So 4 hydrogens, 2 oxygens, what does that equal out to? One small little mumble. So I have confirmation. Are you all calculating it? It looks like a lot of people are sitting there. So I'm trying to get an answer. Do we all agree? Did you try it? Are you involved in this? What'd you get, Matt Kennedy? Keep calculating, then you tell me. What did you get? How'd you get 40? So I'm hearing 36 point something something, right? So 36 grams for just the water. Now you need to calculate out the whole thing, the mass of the total. If we're looking at the whole thing, how many calciums are there? How many chlorines? How many hydrogens? And how many oxygens? So you need to calculate that mass out, the whole thing. So what is our mass of our calcium chloride dihydrate? How much? 100.14. Do we have agreement? What did you say again, Roman? I can't figure out where you might have made a mistake. Did you not add in all 2 chlorines? I don't know. Check your work. 1 calcium, 2 chlorines, 4 hydrogens, 2 oxygens. So what should it be? So what is the mass percent then of our sample? We've got our 36 grams of water divided by 147.02 times 100. What's our mass of our sample? Mass percent of water. Calculate it. What do you get? 24.52%. Are we in agreement? I had 24.51%. So this sample, that means if you have 100 grams of this sample, how many grams is water? Twenty-four point 51% is water. So what you can do, you've actually worked with hydrates before. You don't know it because you didn't know what the compound formula was. Do you remember the ionic covalent metallic lab where you were doing the melting point and you had the blue crystals? What happened when you heated that stuff? It turned white. You know what you were doing? You were kicking out the water. That's all that was happening. So it didn't melt. It just changed color because the water molecules were being evaporated out. So what you could have done was you could weigh out the sample total with the hydrate. It was already in there. If you weigh out that sample, and then if you heat it a whole bunch, you can then re-weigh it, and you can figure out then, based on the formula, how many waters there should be. We will learn how to take this percent data and turn it into formulas probably next week. But now we have gotten to where we have completed our percent composition, and we're going to take a minute and do some practice in your notes packet, or homework packet.